All right, let's see if we can get this started here. So Ashley, which quadrant was your 11 pi fourths in? Quadrant 2? Nice, that's what I got. How'd you get that? So it kept going around? Yeah. Nice. So you're like, as far as 2 pi goes, wouldn't that be like 8 fourths is the number 2? And then you've got 3 pi fourths left to get you up to the 11 pi fourths. So you, like you're saying, you went around a full circle. You did your 2 pi, and then you went 3 pi fourths further. So you kind of got to this spot over here. Nice. Okay. So that is actually right in the middle of my second quadrant. Very good. Very good. Okay. So Elena, do you remember what the XY point is? Yeah, so let's look at the unit circle, and it's that like 3 pi fourths line on the second quadrant. See if you can find that XY point. Yeah, nice. Negative root 2 over 2 for the X, a positive root 2 over 2 for the Y. Okay. So we got our point, which means since I know the X and the Y, I can really find any of the trig functions. They want specifically cosecant at that particular angle. All right, so my cosecant is, it's the reciprocal of sine. Sine is usually the Y value. I'm going to do the reciprocal of my Y value. So my Y value is a positive root 2 over 2. So I'm going to do the reciprocal, and I get 2 over root 2, which I need to simplify. I'm not supposed to have a square root in the denominator, so I will multiply by root 2 over root 2. So I get a 2 root 2 over my nice pretty whole number, 2. Those divide out, and I am just down to a root 2.
You need a negative form?
The reason I did not get a negative is because it was the reciprocal of my sine, or my Y value, and I had a positive Y value at that point. Okay. Anything else? Any other questions?
You have to do a reciprocal?
The reciprocal of sine is my cosecant. That's true. Well, if you're looking at just the straight up x's and y's, another way to look at it would be like 1 over y, which I think is what we saw at the beginning of these notes here. It's for cosecant, it's your radius over y, which on my unit circle, my radius is 1 unit. So it's like 1 over the y. So that's why we did this y value, root 2 over 2. 1 over something is basically the reciprocal of it. If I did 1 over root 2 over 2, I would have to do the reciprocal of the denominator. So I would get a 2 over root 2. So I kind of started right there. I started with the 2 over root 2. Okay. All right, any other questions? These are good ones. Keep it coming. All right, I'm going to move on to number 8 then. Number 8 says, let theta be an angle in quadrant 2 such that sine of theta is 1/3. And you got to find the cosine of theta. There are actually a couple different ways you could do this. I guess, do you want to treat it like it's on the unit circle, or do you not want to treat it like it's on the unit circle? You got to pick. Audrey, what do you want to do? Do you want to treat it like it's on the unit circle or no? Not on the unit, okay, and 80 as well. You guys all want to do it's like it's not on the unit circle. Okay. So what I mean by that is I'm going to put my quadrant 2 over here. I'm going to make my y value Sine is the y value. So I'm gonna make my y value on this right triangle a 1/3. Okay. So what other information could I possibly have on this? Because if I'm going to solve the triangle, don't I need like 2 of my sides and then I can find the missing side? Yeah.
You have opposite, you have length of the opposite.
Ah.
and the opposite.
So this was actually me treating it like it was on the unit circle. You're right. My sine should be the opposite of theta. I'm going to label, here's my theta angle right there. My opposite over hypotenuse. So it's like a 1/3. So at this point, the 3 that's bigger than 1, right? It's not on the unit circle. All right, but I can do some Pythagorean theorem. I can find my missing side here. I used what my sine is.
Yeah.
Sine is 1/3, which if we look at the beginning of the notes, the sine was my y value over the hypotenuse. They put an H or what they put on here? They called it R. Okay. Like your radius of the circle. Oops. Okay. So like my y value, vertical, was a 1. This R, or like the hypotenuse of my triangle, was a 3.
Okay.
And I got to find that missing side now. So let's do some Pythagorean theorem, find the missing side. All right, so I'm going to go a squared plus b squared equals c squared. All right, so if I subtract my 1 over, I'm going to do 9 minus 1 is an 8. And now I have to take the square root of 8, which, let's simplify this. So, oh, how'd you get that?
I split it into 2 and 4.
Oh, okay, so like 8 is a 2 times 4, 4 times 2, whatever. But you know the square root of 4, but we don't know the square root of 2.
Yeah.
Okay, so we simplified this into a 2√2. All right, so here is my missing side here, which at this point I can find whatever trig functions they want. I have all 3 sides of the triangle. They specifically wanted cosine. So my cosine is the x over r. My x value that is found was a 2√2 over the r, which we had was a 3. And that's pretty much as good as it's going to get. I can't really simplify that much more. So there we go. Okay. And then they want me to find tangent by using trig identities. I think you would get the same tangent whether you use that triangle or if you use the trig identities, same thing. The trig identity I think we're going for is the fact that tangent is sine over cosine, which they gave me the sine was 1/3 and we just found the cosine is 2√2 over 3. So there's my sine over cosine. All right, so they're both in terms of thirds. I'm gonna like basically multiply by 3 on both sides, get rid of my denominators. I'm at 1/2√2. Okay, this is not considered simplified quite yet. I'm not supposed to have a square root in the denominator. All right, so I'm going to multiply by √2 over √2. All right, so these guys together multiplies to be a plain 2, and then I've got this other 2 out here. I've got 2 times 2, basically. I've got a 4 here. Okay, so here is the simplified answer, √2 over 4. Okay, what kind of questions do we have? Doing all right. And Sky, I think I didn't catch your question. Which, did I answer that at all? So I just saw that you said, can we do not, I didn't quite catch your question. Sorry, I don't know if I answered it or didn't. Oh, okay. Gotcha. All right. So you guys in the classroom have any questions? Nothing for, so you guys can do this. Ooh, I don't even know what happened there. All right. So you guys can do this type of problem on your own. Yeah, use the unit circle, or I guess it wasn't even the unit circle. It was a different radius. It wasn't a radius of 1. So use that to make a triangle, find whatever trig function they want, and then you can use identities as well. All right, I'm going to move on to number 9 then. Let theta be an angle in quadrant 3 such that cosine is -4/5. Okay, so look, 8 and 9, very similar. I'm going to have you guys take a sec, do number 9. You're in quadrant 3 this time. So kind of do like we did number 8. Draw your triangle, see if you can find the missing side, find whatever trig function they want. I pretty much did like the black, then blue, then purple.
Does that say -2/2?
Oh, sorry, -4/5 is that what you're talking about?
Yeah.
There we go, sorry, -4/5. So you're going to solve this very similar to what we just did.
Can you take this off? This won't turn on.
Yeah.
Sorry, thank you.
Try to be quick though, because we're going to move on, okay? All right, so whenever you guys are ready, I'm going to have Jackson. Are you there, hon? Maybe Jackson's not there. D'Angelo, are you there?
Yes.
Awesome, D'Angelo. So I'll have you do kind of what I started with on this one. I'll have you do the triangle, find the missing side on your triangle.
Okay.
And then once you're done with that, let's see, Francisco, I'll have you find the sine off of that triangle, okay? All right, so D'Angelo, let's see, walk me through this here. First of all, where am I putting this triangle?
Quadrant 3.
Quadrant 3, okay. So this was a negative cosine?
Yeah.
All right, so here's my theta. I've got a right angle. So what about, where do I put the -4 then?
The -4 goes on the x-axis.
The -4 goes right here.
Yeah.
All right, what about the 5? Where does that go?
5 goes on the hypotenuse.
5 is the hypotenuse. Nice. So your cosine is the x over, what are they calling it? The r, the radius, or your hypotenuse, same thing.
Yeah.
So that's what you did. You put your -4 and your 5 there, which means you are missing the y. Okay, so walk me through finding the y.
It's 5 squared minus 4 squared equals 3 squared. Yeah. No, just equals the x.
Okay, equals my x squared. But you basically did this to find a 9. Is that how you got your 3 squared? You said x is 3?
Yeah.
All right, nice pretty whole number. That's nice. Okay, so you solved the triangle. Very good. After you solve the triangle, then Francisco, I'm going to come your way. Francisco, we got to find the sine of theta.
Would it be 3/5?
3/5. That is true. How'd you know it was 3/5?
Isn't the hypotenuse under the adjacent side?
Oh, adjacent is for cosine. I'm trying to find the sine though.
Oh, then the opposite side.
It's okay. So the opposite over the hypotenuse.
Yeah.
Which in other words, when it says the opposite of my theta, it's pretty much talking the like the y value
Okay.
over the rate. So it's the same thing. You could say opposite over hypotenuse or y over r. It gives you the same thing. So
Is the 3 be negative? Because it's-
yes, that's what we were about to talk about. There's one thing we're missing. The length of this is a 3. That is true. But you know how when you take a square root, when I solve for this by taking a square root on both sides? And a lot of times when I take a square root, I get a plus or minus, right? I had to determine, is it a plus or is it a minus? Like positive or negative. And because this 3 went down into a negative y value, I actually had to have a -3 on here, which means that my sine is actually a -3/5. So that just that negative adjustment there, always consider a plus or minus, and you have to choose which one actually represents the space you're in on your graph. Okay, so that's the only adjustment I would make on this. All right, and then we've got to find the tangent. All right, so Jackson, are you there yet? Still not hearing from Jackson? All right, so Adam, I'm gonna come over to you then. How can I find the tangent off the information I have?
You take the.
You good?
You put a sine over the cosine.
Oh, okay, sine over cosine is tangent, and we already found both. Okay, so let's simplify this down. My sine is -3/5. My cosine was -4/5. So if I simplify this down, what do I get? 3/4 and positive 3/4. Nice. Which honestly, if I did that off of my triangle, wouldn't I get the same thing? Tangent is what? Opposite over adjacent. So if I did like the opposite side over the adjacent side, I would still get 3/4. So I should get the same thing either way.
By using the trigonomic identity, you give yourself an extra step.
Yeah, that's true. That's true, you did. All right, Jackson, thanks for letting me know. All right, let's look at number 10 here. And I know I didn't print this, but I'm going to add a number 11 on there. Okay, so number 10, use a calculator to evaluate each trig function. So bust out those calculators, whatever it is you're going to use on the homework or the test or whatever. Bust that out. And I think I showed you before, but I want to brush up on this. I think I showed you the mode, right? You got to be able to go back and forth between degrees and radians on your calculator. Like if I do cotangent of 410 degrees, that would be a totally different answer than if it was cotangent of 410 radians. So for me, I went to my mode and I'm looking at this radians versus degree. Mine currently is in radians. So I'm gonna go down here over to degrees. All right, I pushed enter there. I turned it into degrees. So this is a graphing calculator. Your scientific calculators might do it a different way, but I think you still have to change between your degrees and radians on a scientific calculator. So mess with that for a sec. Let's see if you know how to go back and forth. Okay, so for me, I quit when I'm done here. All right. Notice that's asking for cotangent of 410 degrees, and I don't have a cotangent button. I got a sine button, I've got a cosine button, and a tangent button. I don't have a cotangent button though. So here's what I'm going to do. I'm going to think about reciprocals. Cotangent is the reciprocal of tangent, which means I'm going to do 1 over my tangent of 410 degrees. Okay, so I got this 0.839 yada yada. Hopefully on your homework, hopefully they tell you what to round to. Let's round to the nearest thousandth. Let's go 3 decimals. I'm gonna go 0.839. Okay, first things first, did you guys all get the same thing in your calculator?
Yeah, I have a question though.
Yeah, which question?
So what was the tangent to the power of the -1? What was that for? I know that we used
Oh,
that earlier.
Man, you read my mind. Okay, so yeah, do you see this button? It looks like tangent to a power of -1. What it actually isn't an exponent of -1. It's the notation for an inverse. Do you guys remember us learning an inverse function like f inverse of x, that kind of thing?
Yeah.
Okay, so it wasn't, this -1 isn't really an exponent, it's just a notation that we're talking about. Same thing on my calculator, where they have right above sine here, I have a sine inverse. It's not sine raised to a -1 exponent. It is a sine inverse, cosine inverse, tangent inverse. So let's check this out. If I did my tangent inverse,
Is it kind of like the exponent to, what was it, logarithm kind of thing? Where you rearrange it?
yeah, your inverse function of exponentials are logarithms. So we use that like inverse notation. Well, it looks like a -1 exponent, but it means you're doing an inverse.
Okay.
Yeah, so if I try to do it with that -1, definitely not the same answer. So I guess I have to know the context. Am I doing an inverse function or am I doing the reciprocal? And in this case, I needed 1 over tangent of 410 degrees. So I needed a reciprocal.
Okay, cool. Thank you.
Yeah, no problem. All right, and Justin, oh man, Justin, you found your hyperbolic sine in there. Nice, so we're not using those ones with the H right now. Are we even gonna deal with that this year? You might even have that in one of your college classes. We'll see. All right, so let's take a second here. Is this part B, is that in degrees or radians? How do you know? Oh, it would have to have a degree symbol if we were talking about degrees. There is no degree symbol, so that automatically means radians. So I gotta take my calculator, I'm gonna change the mode here into radians. All right, and they needed sine of -7. All right, so I'm gonna go 3 decimals again. I'm gonna go with a -0.657. Did you guys get the same thing? Yeah? Just bust out whatever calculator you're gonna use on your homework today. I wanna make sure you know how to use it. Okay. And I would pay attention to what they tell you to round to on your homework. It might not be the nearest thousandth, so let's see here. This one, secants. First things first, am I in degrees or radians? Radians, okay. Second thing, do I have a secant button? Ooh, I don't have a secant button. Okay, so then in that case, let's see here. Kislev, what is the reciprocal of secant?
Would it be 1 divided by sine?
Nice. Super close. I do need to do the 1 divided by, totally. Like it's the reciprocal, it's just not the reciprocal of sine though.
Oh, would it be tangent then?
Nope, it's not tangent.
Cosine?
Yep. The reciprocal of secant is cosine. I know it's kind of tricky, like your S's don't go together. It's weird. So this is the reciprocal of cosine, and I'm going to do my pi over 9. Notice I did not use like a rounded pi. I didn't do like 3.14 over 9. I used my pi button over 9. Okay. Is this what you guys got? No? 1 point, I'll go with 3 decimals, 1.064. Okay. Okay, any questions on the calculators? All your trig functions here.
This is way easier than when I did it yesterday.
Really? All right, we're getting it then. How you guys at home doing?
Doing good.
Doing good, all right. So you guys are getting the calculators. Thanks, Justin, thanks, Zadie. Audrey, D'Angelo, okay, all right. Good, good, I've got this last problem here. This is saying the terminal side of theta lies on the given line in the specified quadrant. So find all the 6 trig functions of theta by finding a point on the line. Okay. First of all, what does a terminal side mean? You guys remember that?
Where it ends.
Okay, terminal terminates. That's where it ends. It starts on the positive x-axis. It's going to start right here. And then whatever this line is, that's where I'm going to open up and I'm going to end at whatever that line is. Okay, so this line. Let's talk about this line. Let's put it in slope-intercept form here. I'm going to subtract my 4x over, divide by 3. So in slope-intercept form, here's my line. It's got a y-intercept of 0 sitting there, and a slope of -4/3, like down 4 over 3. Okay. So here's this line. That we're supposed to have a terminal side, like we're supposed to terminate end on that line. All right, so starting on my positive x-axis. Oh, also it says quadrant 4. So notice that this line goes through quadrant 2 and quadrant 4. I need to start on my positive x-axis. I need to rotate all the way around to quadrant 4. Okay, so that's where I'm going to end. So find all 6 trig functions. Let's think about this for a sec here. Why don't I put, I'm going to put a point here on this line. I know that it went, let's see, it was basically a slope of -4/3. If I do this triangle, like I had a -4 for my y value, I had a 3 for my x value. There's my like rise over run, my slope there. So I'm looking at this triangle. All right. So if you guys did some Pythagorean theorem, what do you get for the hypotenuse on this triangle? Nice, +5 for the hypotenuse. So then I can do, now that I have all 3 sides, I can find any of the 6 trig functions they want. In fact, they said find all 6 trig functions. Okay. So at this point, great, I'm gonna go ahead and find sine, cosine, tangent. And then I'll do all their reciprocals. All right. Sine is my opposite over hypotenuse, or in this case, the y over the radius, -4/5. Cosine, adjacent over hypotenuse, or in other words, the x value over the radius, so 3/5 in this case. And then tangent is opposite over adjacent, or in our case, the y over the x, so -4/3. If I know those 3, then I can get their reciprocals. I can get my cosecants of theta, my secants, and my cotangents. All right, so reciprocals, I'm going to, instead of -4/5, I get -5/4. Instead of 3/5, I get 5/3. Instead of -4/3, I get -3/4. Okay, so we found all 6 trig functions. Okay, I tried to color code this in the different steps I did. I figured out where that line was first, and then I kind of drew my angle. Starting on the positive x-axis, I drew that down to where I was going to end on that line. For me, I had to go to quadrant 4. Drew the triangle, found the missing side on that triangle, and then used all 3 sides for my 6 trig functions. Okay. Any questions? No questions at all? Here's my question. Do you guys ever have a negative radius?
No.
No, it's
No.
always been positive. That is true. My radius should always be a positive number. So just beware of that. Yeah, sure, I'll go back up. But are we okay on this one?
So if the radius is negative, then it's undefined?
I shouldn't have a negative radius. I should have a positive. I can have a negative x value or y value because this is my xy axis, or sorry, xy graph. I can have negative x's, negative y's. My radius will be a positive every time though.
Shouldn't happen.
Yeah, it shouldn't. Okay, and there's that.